Hello and welcome to my AMC8 problem review. This AMC8 for this year has been held over a 1-week period, and so some of you may have taken it quite a while ago. But just in case, we have waited a little bit longer to make sure that there are no concerns about an early release of questions, and so I think now is a pretty safe time for us to look at these questions together. Now, in the spirit of the AMC8, this is a contest which you have 25 questions and only a measly 40 minutes. And so we are not going to drag for too long. We're going to get right into the questions. And just a note before we begin, if you haven't tried the questions already and you didn't take part in this AMC8, I would suggest that you try out the problems on your own first and come back and watch this a little bit later. Okay, so this will be a semi-live review in the sense that I have looked at the questions insofar as I have typed out the questions, but I haven't really tried to solve them yet. I don't think that it will make a huge difference that I have typed out the questions on my own, but there are a handful of questions for which I have already thought of the solution by accident while typing out the question in full. So perhaps it is a little bit of a quasi-live solve. Alright, and I think let us begin straight away. The first question, what is the value of 8 times 4 plus 2 minus 8 plus 4 times 2? For the AMC8, you are usually in quite a hurry, so you just want to make sure that you don't rush to the point where you do something too silly. So for the first one, 8 times 4 is 32 plus 2 is 34. For the second one, you do 4 times 2 first, which is 8. 8 plus 8 is 16. And then 34 minus 16 is 18. So that should be option D. For question 2, we have got this slightly messy looking bunch of patterns. But it is simply summarized as what happens when you unfold the pattern. And it's a pretty simple visualization, I guess, because you just need to look at how it was folded and then make sure that you unfold it correctly. So this first corner here, when you unfold it one time, it will become this, and when you unfold it one more time, it will become this. So the gap should be a diamond shape in the middle, which is option E. Question 3. Wind chill is a measure of how cold people feel when exposed to wind outside. There is this formula, and we are just supposed to use the formula. So all the units are correct. Fahrenheit, Fahrenheit, miles per hour, miles per hour. So we can just do a direct computation. And the closest is 23. It's not really very difficult because they did not give 23, 24, 25. So you're not really at much risk of making a calculation error. Question 4. Your numbers from 1 to 49 are arranged in a spiral pattern on the square grid, as we can see. And we are asked how many of the 4 numbers in the shaded squares are prime. I feel that for something like the AMC8, you want to focus on saving thinking time just as much as you want to save calculation time. So you don't need to think of a shortcut. You can just start listing out all the numbers, and that will be perfectly fine. If you can do this mentally, that's also okay, but you don't need to come up with a cleverer counting method. Right? So this is perfectly fine. Now, I can't count. But on the note of a cleverer counting method, if you were, let's say, at this point, you could have realized that, okay, I should get to 36 or 6 times 6 when I reach this square, and so I can sort of fast forward to here instead of manually writing all the numbers. So it's up to you. The difference is probably only about 10 seconds really. Okay, so as you're writing, you can also just mentally check whether those numbers are prime. I'm just writing everything to make sure I haven't messed things up. And 19 is prime, 23 is prime, 47 is prime, but 39 is 3 times 13, so it's not prime. And therefore, we have 3 prime numbers, which is option D. Question 5. A lake contains 250 trout along with a variety of other fish. When a marine biologist catches and releases a sample of 180 fish, 30 are identified as trout. Okay, so this is essentially a proportion question, as whenever we do sampling, we are trying to find out what ratio of a certain type of object we have. So in the sample, 30 out of 180, which is 1 in 6, are trout. Now the lake contains 250 trout, and so therefore that being 1 in 6, the total number of fish would be 6 times 250, which is 1500. Now make sure to read very carefully. In this case, the 180 fish includes the 30 trout. It's not 30 trout and 180 other types of fish, in which case the answer would have been a little different. Okay, question 6. Now, these sorts of things are always a little bit fun because it's like a miniature puzzle. You're supposed to put 2023 into this expression here. Mine's a little bit small, so maybe I'll make it a bit bigger. There we go. And you want the maximum possible value of this expression, which, based on the options there, we see a 0. That certainly cannot be the best. If we put a 0 below, it is going to make everything 0. It just kind of exterminates everything else. And so therefore, your 0 should be placed in the exponent. And it doesn't matter whether we put it on the left or right, I'll put it there. Now once I put it there, we realize that anything to the power of 0 is 1. So effectively, all that we have to do is to try to make the second power as big as possible, and that would be 3 squared, which is equal to 9. Right? There is definitely no way to get 16, and there is also no way to get 18. So we'll put the extra 2 over here. Doesn't matter, actually, it still equals to 1. Question 7. Now, we see a little bit of coordinate geometry, but coordinate geometry in the AMC8 really just requires you to understand coordinates. You don't really need to know anything too complicated about equations. We just have this rectangle with the sides parallel to the x and y axis. And so 15.3, I realize that my scale is a bit off because I've got 15.3 and I've got 16.5. Which means that this would be 16.3 and that would be 15.5. A line is drawn through 0, 0 and 3, 1. Another line is drawn through 0, 10 and 2, 9. How many points on the rectangle? So it doesn't say in, it says on the rectangle, lie on at least one of the 2 lines. Okay, so for the first line, it goes 0, 0, 3, 1. And what I can see is that this line is just going to go up 3 steps in the x coordinate and 1 step in the y coordinate. So we will see that it actually just touches 15.5. So I don't have to worry about it hitting the rectangle anywhere else. Obviously, if it goes in that angle, that's going to be 1 point. Now the other one starts at 0, 10 and then 2, 9. So I'm not going to put the points down too carefully. I'll just put it something like that. It basically goes 0, 10, 2, 9, and then each time the x coordinate goes up by 2, the y coordinate goes down by 1. So it goes 10, 5, 12, 4, 14, 3, And 14.3 means that it's here, and then by the time it gets to 16, it's at 2. So this is just going to be under, which is why I wasn't too concerned with getting things to scale. It doesn't intersect at all. So therefore, there is only one point which is lying on one of the two lines, and that is the vertex 15.5, giving us B once again as our answer. For question 8, there is this ping pong tournament. Each player competed against each of the other 3 players exactly twice, and we are given the win-loss records represented using 1s and 0s for 3 players, and we want to know the record for the 4th player. Now, this is question 8 of the AMC8, so you must always remember that the location of a question is also kind of a hint. It hints at the fact that this surely cannot be too hard. And so we don't want to spend too much time worrying who played with who, when, and who beat who, how many times. An easier way to think about it is that they played 6 rounds. In each round, there will be 2 winners and 2 losers. That's how these games go. And so we look at each round. If there are already 2 winners and 1 loser, that means that our 4th player, TO, has lost. And if there are, let's say for the 4th round, there are 2 losers and 1 winner, that means that the 4th player, TO, is a winner. And so if we just write this down for all of them, only the 4th and 6th round would be a win for TO, and that option would be A. Question 9. Malaika is skiing on a mountain. The graph below shows her elevation in meters above the base of the mountain as she skis along a trail. So this is a elevation time graph. In total, how many seconds does she spend at an elevation between 4 and 7 meters? Okay, so let's draw a line across. For 4 meters, that would be here. It's already marked out. And 7 meters, that's also marked out here. And so that would correspond to this portion here, this portion here, and this portion here. Here, this would be 2 to 4, that's 2 seconds. Here, this would be 6 to 9. So that would be 3 seconds. And then this would be 12 to 14, which is 2 seconds. And this is a little bit strange. Why does it actually have the option 6, 8, 10, 12, and 14? Did I type wrongly? Let me check. Or did I read the question wrong? Oh, my drawing was too bad, wasn't it? Okay. Yes, and this is why you need to be careful when you draw. I'm looking at this carefully, and then now I realized the problem was that my line was too uneven. It was too uneven that I did not realize that actually it was not supposed to be 3 seconds. It was supposed to be 4 seconds. My bad, that was really silly. And yes, that means that 2 plus 4 plus 2 would be 8 seconds. There we go. Question 10. Harold made a plum pie to take on a picnic. He was only able to eat 1/4 of the pie, and he left the rest for his friends. A moose came by and ate 1/3 of what he had left, and then a porcupine ate 1/3 of what the moose left behind. This what is left questions tend to be really simple. We just need to keep on multiplying together what is left. So he ate 1/4 of the pie, so 3/4 is left. And then after that, the moose came by and ate 1/3, so 2/3 of that is left. And then the porcupine ate 1/3 of what was left behind, so 2/3 of that is what is left. So after doing a bit of cancellation, we are just left with 1/3, which is option D. So we're making decent time. It's been about 12 minutes or so since we started working on the questions, and yet that is only par for the course. We are on the easiest 10 questions, and at the same time, you have only got 40 minutes for 25 questions. So in fact, even all of the talking that I'm doing, we should be cutting it down. But I think it'll be weird for you to just see me writing. Question 11. NASA's Perseverance rover was launched on July 30th. That is completely irrelevant, I think. After traveling 292,526,838 miles, that's a little bit relevant. It landed on Mars about 6.5 months later, which is closest to the average speed in miles per hour. Okay. So we need to find out how many hours is 6.5 months, and we need to divide, and thankfully all the options look like they're pretty far apart. So I'm going to estimate this to be about 300 million miles. I'll estimate 6.5 months to be about 200 days, and then 200 days times 24 would be 4,800 days, which would be close enough to 5,000 days. Right? We are being very crude here. And now if I divide, I just need to make sure I get the correct number of zeros in. So 300 million divided by 5,000. I like to put it using these abbreviations because 1 million divided by 1,000 is 1,000. So I can cancel off 1,000. 300k divided by 5 would be 60k. And so 60,000, which is option C. Question 12. Figure below shows a large white circle with a number of smaller white and shaded circles in its interior. What fraction of the interior large white circle is shaded? So essentially, we can just treat the small squares in the grid to have a length 1 unit or 1 cm, I'll call it 1. And we just do a lot of addition and subtraction. So the big circle has radius 3, and so pi times 3 squared is 9 pi. Now, each of these would be pi times 0.5 or half squared. So it's 3/4 pi. This one is pi times 2 squared minus 2 of these circles, which is pi times 1 squared. So 4 pi minus 2 pi is 2 pi. And so therefore, what fraction is shaded would be 2.75 pi divided by 9 pi. Cancel off the pi, multiply by 4 at the top and bottom, and I get 11/36. Formatting's going a bit off. Okay, question 13. Along the route of a bicycle race, 7 water stations are evenly spaced between the start and finish lines. There are also 2 repair stations evenly spaced between the start and finish lines. The third water station is located 2 miles after the first repair station. How long is the race in miles? Now, technically, you can actually just use any one of these as your guess and then adjust it from there. But regardless of what you use, you just need to understand what does it mean to have 7 water stations evenly spaced. It means that you have got actually the start, you have got the finish, and then 7 in between. Now, if you have got 7 dividers, you don't have 7 intervals, you actually have 8 intervals. So it basically means that they come at the 1/8, 2/8, 3/8, and so on, and this is the third water station which I want to pay attention to. There's also 2 repair stations, so that would be at the 1/3 and 2/3 marks. And again, I care only about the first repair station. And so the distance between the 1/3 point and the 3/8 point is 2 miles. So 3/8 minus 1/3 is 1/24, and 1/24 corresponds to 2 miles. And so therefore your length of the race is 24 times 2, which is 48 miles. Question 14. Nicholas is planning to send a package to his friend Anton, who is a stamp collector, to pay for the postage. Nicholas would like to cover the package with a large number of stamps. Suppose he has a collection of 5, 10, and 25-cent stamps with exactly 20 of each type. What's the greatest number of stamps Nicholas can use to make exactly $7.10 in postage? That's a really strange thing to do. But if I want the greatest number of stamps, and you've got 20 of each type, we would be a bit tempted to ask, can I just use all of the 5 and 10 cent stamps? Let's try that. All right. So if I use 25 cents, I get $1. I have 20 10 cents, I get $2, and so I'm left with $4.10. Now, I can't get that exactly using 25-cent stamps, right? And so therefore, I would need to do a little bit of adjustment. Now, the closest I could get would be $4.25. That would be with 17 25-cent stamps, but this would currently give me $7.25. So I want to take away as few stamps as I can to get exactly 7.10, and so what I would do is just to take away 1 10-cent and 1 5-cent, so 19 of each. Right, if I do that, then I am going to exactly subtract off the 15 cents that I need. So this is correct, and down here I've got 55 stamps. And this is good because it's the largest option, so I don't need to worry about whether I have missed something more clever than this. It's already the largest option, and I found a way to do it, so it must be correct. Okay, question 15. Viswam walks half a mile to get to school each day. His route consists of 10 city blocks of equal length, and he takes 1 minute to walk each block. Today, after walking 5 blocks, Viswam discovers he has to make a detour, walking 3 blocks of equal length instead of 1 block to reach the next corner. From the time he starts his detour, so this is the time when he starts his detour, at what speed in miles per hour must he walk in order to get to school at his usual time? But the first thing I want to do is to just find out what's his usual speed. And it says half a mile, and normally he takes 10 minutes. So if I multiply by 6, it means that it's 3 miles in 1 hour, in 60 minutes. So his usual is 3 miles per hour. Now, he is going to be walking at the usual speed for the first half. So after walking 5 blocks, then he discovers he has to make a detour. So we can see that in this path, he has had to make 2 extra lengths, right? Because they are blocks of equal length. And so he had to go 7 units instead of 5 units. So it's 7 over 5 times of the usual, and so therefore his new speed should also be 7 over 5 times 3, which is 21 over 5, and that should be 4.2 miles per hour. Okay, next up is question 16. The letters P, Q, and R are entered into a 20 by 20 table according to the pattern shown below. How many P's, Q's, and R's will appear in the completed table? If you look at how much time we have spent, we do not have much time to spend down here. And a 20 by 20 table is very big, but if we look at the pattern, we kind of expect all of them to be roughly appearing the same number of times as all the options shows us. So if we can kind of cast out sets of 3 that have one of each letter, then the leftover will allow us to figure out which letter appears the most often and by how much. So forgetting this for a second, I'm just thinking of a 20 by 20. And anytime when I have a block of 3, it will contain one of each, right? No matter where I mark out a block of 3. So if I've got a 20 by 20, I'm going to first cast out an 18 by 18. I can do that. And all of these should have the same number. And in fact, I can also cast out this 18 by 2 and this 18 by 2. That will also come in blocks of 3. And so actually, this is the only thing that's going to be left. And that corresponds to this block down here. Now, this block down here has 2 Q's, 1 P, and 1 R. And so if I were to further grab out one block of Q, P, and R, it means there should be one extra Q compared to the other 2 letters. And looking at the options, that would be option C. Question 17. A regular octahedron has 8 equilateral triangle faces. Just describing an octahedron and then folding it. And which numbered face will end up to the right of Q? Right, so apologies for the slightly low res image. I didn't get the original version for this question, but Q is here and the question mark to the right is down there. Now, it is also important if we were to look at the direction of the letter Q, because if we have the direction of the letter Q, we do know that it has to follow the orientation. Otherwise, this can be rotated in many different ways and almost anything could end up to the right of Q. Now, one thing that can help for an example like this would be to realize that, assuming that you can't visualize it, for an octahedron, it kind of comes in a checkerboard pattern. Now, what do I mean by a checkerboard pattern? It means that you can say that the neighbor of my neighbor cannot be my neighbor, if that makes sense. Right, so this is, let's say, unlike a tetrahedron where everyone is everyone's neighbor, or a square where the neighbor of your neighbor could be your neighbor. Now, that would not happen in an octahedron. Again, assuming that you can't visualize this, what I can do is to note that these 4 are going to kind of be in alternating positions, which I will just highlight a couple of them from the other 4. So that will reduce your search space a little bit. It reduces your search space a little bit because it means that your Q has to be opposite either 1, 2, 4, or 4. So it has to be next to 1, 2, or 4. It certainly will not be the number 6. So this is sort of a small improvement if you cannot visualize it entirely. Now, another thing that you could do is to just try to figure out what is opposite what. Right? And so if Q is here, I have no idea what's next to Q. I have no idea what's opposite Q. But if I can look at some other pairs, I can look at 4 and say that this number 4, it shares a vertex with all the other faces except for Q. And so 4 would be opposite Q, which means that it is not going to be 4 either. Now, by symmetry, we can also say that 5 will be opposite to 1. And then your opposites will also be 3 and 6 and 2 and 7, because your opposites should have different colors. So this will help us a little bit if we are trying to do a little bit of placements, because if let's say that our visualization is very bad, we can still say that, well, Q is next to 6, and then 6 is opposite 3. Right? So you will be able to fill in some of those down there. Of course, this will still require a little bit of visualization, but I just wanted to give you as much help as we can in case, like me, your visual skills are a little bit lacking. I really don't know what else to say apart from the fact that the one that is opposite is going to be actually the number 1. So the one that's going to be to the right is going to be the number 1. It may not be that shocking considering that they belong to this very long middle block that it ends up wrapping back around. But to be honest, I don't really have the ability using just a pen to show you how it would appear. So if you really want to cut it out and fold it, that's an option in the AMC, assuming that you have paper handy, scissors handy, and you are able to do a bit of artwork as fast as you can. So I'm just going to say the answer is A and leave the rest of this to you. Okay, now for 18. Greta Grasshopper sits on a long line of lily pads in a pond. From any lily pad, Greta can jump 5 pads to the right or 3 pads to the left. What's the fewest number of jumps Greta must make to reach the lily pad located 23 pads to the right of her starting point? So I guess we can just try to go as close to it as possible, and then after that use the 3 pads to the left to backtrack if we overshoot. Okay, so if I start from 0 and I want to go to the next multiple of 5 after this, that would be 25, but I cannot go back by exactly 2 steps. So -2 wouldn't work. -7 also would not work if I stop at 2030, but at 2035 it would work. So I can't do any better than this. Here there's 407 steps, and then there's 4 more steps. So 407 plus 4 is 411 steps. Right, the order doesn't matter actually, because if I do +5 and then -3, or if I did +5, +5, -3, -3, versus -3, -3, +5, +5, I end up at the same spot. So it's just the total number of moves is like adding 5 and subtracting 3. Okay. 19. An equilateral triangle is placed inside a larger equilateral triangle so that the region between them can be divided into 3 congruent trapezoids as shown. The side length of the inner triangle is 2/3 the side length of the larger triangle. This is really not drawn to scale. Now, the ratio of the area of one trapezoid to the inner triangle. What I want to do is actually just to say that the trapezoid's area is just 1/3 of the remaining area, right? So by similar triangles, if the side length of the smaller one is 2/3 of the side length of the larger one, this would be 4/9 of the whole triangle. It doesn't really look like 4/9 because it's not very to scale, but it would be 4/9, 2/3 squared. So the rest of it will be 5/9, and 5/9 split into 3 equal parts will be 5/27. And so the ratio, if I multiply by 27, I would get 5:12. Question 20. Two integers are inserted into the list 3, 3, 8, 11, 28 to double its range. The mode and median remain unchanged. What is the maximum possible sum of two additional numbers? Okay, so we need to first get all the named entities noted down. The range is currently 28 minus 3 is 25. The mode is currently just the one that's repeated, which is 3. And the median is just the one in the middle, which is currently 8. So my 3, 3, 8, 11, 28, what's going to happen is that I'm going to have to put numbers to expand out the range. But one of them should go to the left of 8 and one of them should go to the right of 8. So that's still the median. And I should be careful of repeating any numbers just to make sure that 3 is still going to be the mode. Now, there are, I guess, two possibilities here. One possibility is that I don't touch the 3. So if I don't touch the 3, it means that I'm going to add on just, well, a number 3 down here. And then double the range means that the range becomes 50. And so I put a 53 down here. Now that is going to give me a sum of 56. And it would not change the mode, it would not change the median. Now, if I want to make this sum bigger, one way that I could do it is to move this 3 inside the list. And so if I move the 3 inside the list, 3 will still be the minimum. And I just need to keep it to the left of my number 8. So I could actually move this to 7 and 53, and that would be a sum of 60. Now we know that the 53 is the biggest that you can get. Right? So your large number, you can never go past 53 because then the range would be at least going to exceed 50. You also have to make sure that your other number is to the left of the number 8. So you cannot do better than 7. It cannot be 8 again. Because if it were 8 again, then 3 would no longer be the mode, because 8 would also be the mode. And so therefore, the best we can do is really the 60, and we can decide not to look any further. Question 21. Lina writes the numbers 1 to 9 on separate cards, one number per card. She wishes to divide the cards into 3 groups of 3 cards so that the sum of numbers in each group will be the same. How many ways can this be done? This is pretty funny actually, because I think I set a question similar to this in my other AMC10 mock paper. The other paper being one where we had to have a nearly magic square. So this is the same idea as that. You just need to know the number of ways to divide them into 3 groups. And how I like to do this is pretty simple. First of all, if you weren't already aware, the sum of numbers from 1 to 9 is 45. And so this is a total that we are going to divide by 3. Right? So 45 is this not so secret sum that we're going to divide into 3. And once you've divided into 3, we want to find out how can I split into 3 groups that each sum to 15, which you might realize is actually pretty small. And how I like to think about it is that I have got three very big numbers, and the three very big numbers cannot go into the same group because even 8 plus 7 would already be 15. So I can think of this as the 9 group, the 8 group, and the 7 group. And I need another 6, 7, and 8 more to reach the total of 15. Right, so my numbers, of course, I'm left with 1 to 6. So we just have got a couple of ways to get 6. Let's start with that. If I did 1 and 5, then 7 can only come from 3 and 4, and then 2 and 6 will work. So that will get everything. The other way would have been to do 2 and 4, in which case if I want to get 7, that can only be 1 plus 6, and then this would be 3 plus 5. And that's it basically. You only have got 2 ways to do it, and that's the reason why magic squares are very, very constrained. There just are not that many ways to split it into 3 groups where the sum of numbers will be 15 for each group of 3 numbers. Question 22. In a sequence of positive integers, each term after the second is the product of the previous 2 terms. The 6th term is 4,000. What is the first term? Now this is quite a cool question actually, because it is a sequence where they didn't tell you the starting, they just told you something in the middle. But there are positive integers, so we can actually talk about things like factorization. But more on that later. I just want to know how this sequence looks like, and since I don't really know anything about the first 2 terms for now, I'll just call them A and B. And then I'll just write down what the next few terms are. So A times B, B times A times B would be AB squared. The next one would be A squared B cubed. And then the next term would be A cubed B to the power of 5. Okay, so this is going to be my term. 6th term, I mean. Now, 4,000, I'm going to factorize it. It's 4 times 1,000. And 1,000 is 10 cubed. So 10 cubed is 2 cubed times 5 cubed. So I get 2 to the 5 times 5 cubed. What do we know? That's the same combination, isn't it? 5 and 3, 3 and 5. Okay, so it is pretty clear then that one way to do it will be A equals to 5, B equals to 2. That will turn out to be the only way, but for the AMC, I will just take my winnings and run. A equals to 5, so my answer is D. Question 23. Each square in a 3x3 grid is randomly filled with one of the 4 grey and white tiles shown below. This reminds me of a Japanese puzzle called Shaka Shaka. If you have seen it, then the pattern below will look very familiar. And the question is asking you what's the probability that you will get one of these large grey diamonds in one of the smaller 2x2 grids. Something like this, basically. And this is assuming that you do it completely at random. These diamonds, once again, don't really coexist. Right? So when in a 3x3 grid, there are 4 diamonds. Right? It could be here, 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 and here. And each of those diamonds, if you have one of them, you cannot have another one. So basically, we have got 4 essentially independent targets that we might want, and we can just add up their probabilities since all of these are clearly going to be equally likely. So let's just focus on this one. How did this diamond become a diamond? Well, this diamond came from making 4 consecutive good choices. And the good choices have to be exactly that. It is not 1 of 2 or 1 of 3. It has to be exactly this. So the chance of getting this precisely is 1/4 to the power of 4, which is 1 over 256. It's 1 over 256, and so if we have 4 different chances to make this happen, your probability would be 4 times of this, which is 1 over 64. question 24. We are almost there. The time that I see is 45 minutes, so we are slightly over time, but I think acceptably so considering all of the talking. So here we have our isosceles triangle ABC, and segments are drawn parallel to AC such that the shaded portions of ABC have the same area. Now they're not half the area, okay? So they are just some portion of the area, and we are basically told that these are the same area if you take a height of 11 on one end and you take a height of 5 on the other end. Now this diagram that I have here is already pretty misleading because it would look as if this is slightly above, and so the answer should be slightly more than 16, but what do we know? All the options are less than 16, so clearly you shouldn't trust the diagram too much. Instead, we should probably just use a little bit of algebra coupled with similar triangles, because when you have parallel lines in this so-called pyramid shape, you're always going to have similar triangles. So the smaller triangles here are both going to be similar to the whole thing, and when we have similar triangles, we can find out what fraction of the area is occupied. So for this one down here, I'm going to actually use the unshaded areas have the same area, because if the shaded areas have the shaded portions have the same area, then the unshaded portions also have the same area. So the fraction occupied by this would be 11 over h squared. And the fraction occupied by this would be 1 minus the fraction from the shaded area, and the shaded area has height h minus 5. Maybe I should keep my formatting a little bit more consistent, right? So I'll write it as h minus 5 over h whole thing squared. So both of these are supposed to be the same, and so if I say that both of these are the same, it basically means that this plus this should be equal to 1, which kind of then tells me that I should have just used that in the first place, right? That the unshaded of one and the shaded of the other is the same. Well, never mind, we got there through a slightly longer way. So 11 over h squared plus h minus 5 over h squared equals to 1. And so both of these have the same denominator of h squared. So 121 plus h squared minus 10h plus 25. We use a little bit of algebra. And if we were to just multiply over and cancel off the h squared, we are left with this, which simplifies to h is 14.6. Usually the AMC8 requires a little bit more algebra, but only right to the very end. So the earlier parts don't use too heavy algebra, but the last couple of questions can just take a slight tiptoe into a little bit of quadratics and expansion. Last problem. 15 integers A1, A2, A3 to A15 are arranged in order on a number line. The integers are equally spaced. Okay. They have the property that A1 is from 1 to 10, A2 is from 13 to 20, and 241 to 250 is the range for A15. What is the sum of digits of A14? Okay, so they're all integers and they're equally spaced. So the trick here is that your A1 is 1 to 10 and your A15, which is somewhere from 241 to 250, whatever the difference is, so let's say that the spacing is D for difference, the difference between them would be 14D. because there are 14 intervals. And the range of possible differences, based on what we know now, is from 241 minus 10 is 231, and then 250 minus 1 is 249. So this is the range that we are talking about. Now if you do a little bit of long division, you will realize that only 238, which is 14 times 17, is a multiple of 14. And since that's the only multiple of 14, that must be the difference. So the difference must be 238, and the difference must be 17. Now if the difference must be 17, and the difference from A1 to A15 must be 238, already we have got enough information to solve the question. Right, so the first thing is that I can just look at A1, A15. How would they differ by 238? Well, I need to at least have 3 241, and this will go all the way to, well, I can't get to 250, right? If I go until 10, I only get until 248. So that's the first thing. The second thing is that A1 and A2 also have to differ by exactly 17. And the range is even harder to satisfy here because of the 13 to 20. So I only have 118, 219, and 320. That's it. If we look at this here, the only overlap is here. This is the only overlap between the two sets of pairs, such that A1 can be the same in both cases as it should be. So A1 would therefore be 3. This is 241, and if I want A14, I just backtrack by 17. Sum is 224, and the digit sum would therefore give me 8. There we go. So I think this was a pretty decent AMC8, not too heavy on algebra. And the questions, some of them seem to be pretty novel, which is nice. But I think that for those of you who are more experienced, it would have been achievable to finish this in the time limit, seeing as I have been talking a lot and still we are done in about 15 minutes. So I hope you had fun. Let me know if I made any mistakes. This is still sort of a live solve, so I may have messed up something. Maybe the octahedron was wrong or something like that. Please let me know. And if you have any other comments, just feel free to share. So thanks for watching, and see you guys again soon.